Hello, welcome to Mind Chat. My name's Philip Goff.
Hello, welcome to Mind Chat. My name's Keith Frankish.
It's been a while, Keith. How you doing, my old mucker?
It has been a while. We've had one or two ups and downs, haven't we? That have interrupted the normal flow of these things. I'm okay. I'm good. How about you?
Oh, I'm not too bad. It's been a bit difficult, as you know, Keith. I lost my dad early this year, so that's been obviously quite difficult. Taking a bit of time off work, partly why we haven't done Mind Chat for quite a while, but I'm all right. Getting back into things, and I'm enjoying actually. So much crazy with book promotion before Christmas. It's nice just to get back to quiet, calm, drinking tea, working on academic articles, meeting students, enjoying that normality a bit. So that's nice.
Yes,
But
good. Yeah, I'm sure all the viewers will join with me in expressing our condolences, Philip. I know it's been a very hard time for you.
Oh, thanks, Keith. But yes, life goes on. Yes, so exciting news on Mind Chat, developing the thing where we've now got a handful of very kind subscribers, not subscribers, Patreons. And so we're going to use this money to develop this project a little bit. Finally, this is the first episode where we've got rid of that bloody duck, that bloody StreamYard logo. Paid the overpriced fees for that, and gonna hire someone to edit the videos and stuff. So hopefully get this a little bit more nicely produced. But I don't know, it's hard to get. I find on YouTube everything's getting so professionalized, isn't it? And it used to be very amateur, but it's sort of big bucks now, and everything looks very, very sophisticated. So I don't think we'll quite get that. I think we'll still probably be the podcast with the lowest production values and the greatest philosophy, but hopefully we can get it a little bit more finely tuned, you might say.
I think it's part of our charm. I think our amateurishness is part of the charm. Amateurish production, professional level philosophy. That's what we should go for, as opposed to the inverse. I'm kind of missing the duck now.
Anyway. I'll buy you a duck. I'll send you a rubber duck. Yes, so we got lots of guests lined up. We finally got our much delayed Christmas special. I think is happening. I haven't quite confirmed that with you, Keith. April the 18th, possibly, if you can do that. And we got special. Andy Clark booked in. It should be an Easter special, really, shouldn't it? Maybe we'll do an Easter special. Andy Clark in October.
Sorry.
Say again, sorry?
I was suggesting you can get dressed up as the Easter Bunny.
Now that is a good idea,
isn't it?
Replace the duck with a bunny. Do you know, Keith? I'd bloody love that. Actually, I will look into that. I will very much look into that.
Please do it, please.
Who else we got? Finally got Annika Harris booked in for May. And then March, I guess, is the next one. We'll get something sorted for them. Not quite hammered down, but yes, it's up and running. Mind Chat is back. It's very exciting. So yeah, if you do want to support us, do please subscribe to this channel, like the video, comment, all these easy to do things. Help us get this content out a bit more. If you want to be a Patreon, $2 to make yourself feel better, $10 to join our Mind Chat community. Have a little chat after the episode if you like, or something akin to that. Anyway, you want to know the guest for today?
I'm all anticipation.
Well, it's very exciting. One of the most interesting scientists working on consciousness these days. Someone we've both been Twitter buddies with for a long time, but yet to meet in person. I'm sure we're not meeting in person, but almost in person. Shall I bring them on?
Please do.
It is Kevin Mitchell. Welcome to Mind Chat, Kevin.
Hello, thank you. That's the most rousing introduction I think I've ever had, Philip. Thanks a lot.
Welcome, Kevin.
We like to do it big on Mind Chat.
That's right.
Well, I'll just briefly introduce you, Kevin. So, Kevin is Associate Professor of Genetics and Neuroscience at Trinity College Dublin. And his research focuses on the genetic program that specifies the wiring of the brain, and how that's relevant to explaining variation and disorder in human psychological faculties. And in 2018, he published a very well-received book called Innate, subtitle, How the Wiring of Our Brains Shapes Who We Are. And that was published in 2008 with Princeton University Press, and he's just published another book, a follow-up book, which I have a copy of here, which is called, as you can see, Free Agents, How Evolution Gave Us Free Will. And that's what we're going to be talking about today. So, let's get into it. So, Kevin, you've written this wonderful book, Arguing for Free Will. Now, I suppose free will is sometimes thought of as a philosophical problem, metaphysical problem. Now, you're a neuroscientist. Philip's got a copy too. You're a hands-on neuroscientist interested in genetics. So, what prompted you to write this book? How did you think that, what light can neuroscience shed on this perennial philosophical topic?
Yeah, it's a great question. And it was prompted by a few things. So one thing was that after I wrote Innate, which is about this idea that we're not blank slates, that we do have predispositions that are based on the way that our brains are wired, things that we had no control over, right? Based on our genetics, based on our very idiosyncratic brain development. So we have, personality traits and things, those affect our decision making. In fact, that's just what personality traits are, is just descriptions of patterns of decision making, right? So people used to ask me sometimes after I talk about that, well, what does this mean for free will? If I'm just wired this way, am I just sort of acting out my pre-programming? And where does it leave any control for me in the picture? And that really got me, started thinking about it more seriously. Of course, I entertained some thoughts about it like many people do as a dilettante. But then the other aspect that kind of made it more timely, I think, for me, was that there are many neuroscientists out there, some very vocal, prominent ones, who will claim that neuroscience is actually showing very clearly that we don't have free will and we couldn't. And then, of course, there's some physicists who claim the same thing. So for me, it was an interesting time in that neuroscience is making amazing progress in explaining how the brain works, and in a sense, how the workings of the brain underlie cognitive operations. But in some sense, some neuroscientists look at that and go, well, here's the mechanisms by which decision-making happens, and it's the mechanisms that are making the decision. You just evaporate from that picture. You're just not involved in that process at all anymore as an entity, as a whole self. And so that bothered me in a sense, because I feel like I'm a self and I feel like I'm making decisions like everybody else does. So the phenomenology of our experience is so is so strong that the idea that we could dismiss it all with just some evidence from some fMRI experiments or some EEG recordings or something, it felt a bit facile, frankly. It felt just a bit too easy to say, well, look, here's these neuroscience experiments, and that's science, man. You can't argue with that. It just proves that the whole phenomenology of our experience is an illusion. And so what I wanted to do was see, well, just of course embrace the materialist physicalist kind of view that says, yes, the brain is a physical thing, and there shouldn't be any magical spirit or ghost in the machine that we need to invoke. But maybe there's a non-reductive kind of view that we can take, where the self as a holistic entity still can have some power, some macroscopic kind of functionality can emerge that will allow us to get a naturalistic view on what we call free will, and that of course has all this metaphysical baggage to it. I wanted to kind of ground a discussion of that in the relevant neuroscience, because I think a lot of the neuroscience that bleeds into that philosophical discussion is actually not that relevant. And there's a whole neuroscience of decision making and cognition and behavioral control that's really fascinating. And those two areas don't often make as much contact as I think they should.
I think fantastic. So, and I think that's one thing I think we should emphasize about the book. But no matter what you think about free will, about the philosophical issue, there's a huge amount that neuroscience can tell us about the mechanisms involved in self-control. And everyone can agree on those mechanisms are real, that they're there, that they're doing stuff. I mean, how exactly that, whether that solves the problem of free will, that shows we do have free will, or shows that we don't, or whatever, that's to some extent an interpretation, I guess, of the neuroscience, and you are full on. But this book, one of the wonderful things it does, I think, is it introduces that neuroscience and that evolutionary biology beautifully. And so I think probably the first 6 chapters of this book, which tell the story of the evolution of mechanisms of autonomy, of self-control within living creatures, I think pretty much everyone who's interested in free will could read those chapters and think, yep. I agree with all of it. Well, they're learning all of this, and it's something that everyone has to take account of. So I think that's one wonderful contribution you've done here, is that you've informed the debate in a very accessible way with knowledge of the relevant neuroscience and evolutionary biology. So that's one reason I would recommend this book to anyone, no matter what you think of the.
I really appreciate that, Keith, and that of course was the job I set out to do. And I mean, the reason for taking that approach, for taking that evolutionary approach, was first of all that if we're talking about free will and we're sort of thinking of it as this capacity for rational control of behavior, for to decide what to do, just the capacity really for any organism to act, to be a cause of things in the world, right, to make things happen. So if that's that's the broad sort of description of what we're after, the phenomenon we'd like to explain and understand, then it didn't, make sense to me to just start with humans, the most complex instantiation of those capacities that we know of. And it made more sense to take this evolutionary approach and say, actually, well, we're going to need some concepts here. Yeah. We're going to need to ground some concepts like purpose and meaning and value. And even just action and causation and things, those are things that are going to be difficult to fully grasp in this massively sophisticated, elaborated version. So what I wanted to do was try to figure out, well, even let's start with just the simplest living organisms. How do they do anything? And then build up and scaffold from there. And that just felt like, first of all, a good way to approach the understanding, but obviously it's also the way nature did it, right? It's the way nature got there. So trying to follow that trajectory was the goal there. And then, as you say, of course, it leads into much more complex philosophical issues once you get to humans.
And I should say, you even go further back than the origins of life. You discuss the emergence of life from inorganic processes, and I think that's that chapter on that is, I think, probably one of the clearest, most accessible introductions to what we know of that that I've come across anywhere. And so you really tell the big story.
Yeah, it's funny. I didn't expect to get into that when I started writing the book, but the more I thought about it, the more I thought, you know what? The real question that we're after is this question of agency. Right? How can living things make things happen and do things? And that ultimately is the primary distinction in my mind between living and non-living things. And it doesn't get talked about much. If you open a biology textbook and you look at the list of characteristics of life, doing things, agency is just not going to be on that list. There's going to be like respiration and reproduction and metabolism and those kinds of things, right? But the very fact that living things, that there's just whole other levels of causation that I think get introduced into the universe, frankly, that don't apply in the merely physical world. So so I got into the sort of what I take to be the most plausible theories around the origin of life, what it means to be a living thing at all. The idea that living things have to do work to keep themselves organized in a certain way, out of equilibrium with their environment. They don't want to become one with the universe. And so they're working a way to keep this pattern of processes going through time. And that, to me, actually, grounds the notion of selfhood. What does it mean to be a self? Is to have this pattern that persists through time, and it's that continuity through time that I think is the really key concept there. That it feels to me like you just have to ground it at that very basic level.
But as a good evolutionary scientist, of course, you don't. Life doesn't just spring into existence at some at some determined point. There's a gradual process by which life emerges, and you tell the story of this, of complex macromolecules and how lipid barriers form and so on, and how we move from non-life to life. And so the story is a gradualist one throughout. I mean, you talked of new levels of causation. I would say new levels of causal explanation, but we'll get to that later. So maybe Philip, do you want to just sort of bring in the philosophical angle on this? Now we've got
just to second Keith's thoughts about the book. I thought the really great mix of sort of cutting edge neuroscience and the sort of factual scientific stuff, and also this kind of driving idea of making sense of agency, and maybe that's been a bit neglected and so on. But yeah, maybe just try and, just for the viewers, to connect the content of the book to how philosophers tend to think about these things. So typically philosophers divide, and maybe you don't like these categories, perhaps. It's always an option when you're doing philosophy, as I tell my students, to reject the terms of the debate you're being presented with. But anyway, the standard view is that we can divide theories of free will into three categories. So you've got the libertarian, the compatibilist, and the hard determinist. So the libertarian thinks, let's go the other way around. The hard determinist thinks that the universe is deterministic. From the Big Bang onwards, everything is it's totally determined from past states of affairs, what's going to happen at the next time. And because of that, we're not really free, right? Everything's determined. It's not up to us, and therefore we're not really free. That's the hard determinist position. The polar opposite, the libertarian position, does that the other way around. Says, well, we do have free will. For whatever reason they think that. We do have free will. Therefore, the universe can't be deterministic, right? Because if it were deterministic, things wouldn't be up to us. We wouldn't have free will. But we do have free will. Therefore, the universe can't be fully deterministic, at least. So they're polar opposites, but they at least agree on something. They agree on one thing, namely that free will and determinism are incompatible. So one goes for free will and one goes for determinism. Then you've got the middle ground position, the compatibilist position, for what it's worth, the most popular position in philosophy, but, not a popularity contest. But the compatibilist position says, we can have both. We can have our cake and eat it. Yes, the universe is deterministic, or for all intents and purposes, but we can still have freedom. And it is an interesting observation, just finding that is, what is it? 56% of philosophers on the Phil's paper survey sign up to that. Whereas I find, like, outside of philosophy and science and the public, it's a much less popular position. In fact, people often sort of assume it's not true or don't know about it. But anyway, it's an interesting.
So you appeal to Phil papers when it goes the way you want. You appeal to the people when it goes the other way. Oh.
That's not true, Keith. I'm not a compatibilist. So no, it's just an interesting sociological observation that. But anyway, that is a distraction that I didn't mean to bring up. But I'm somewhat agnostic on these things, but I'm not necessarily a. Anyway, what I want to ask you is, Kevin, do you like those categories? Do you think your view fits into one of them?
Yeah, I don't like those categories, really, and I actually would take the option that you offered to reject the terms of the debate, in the sense that I think even the libertarians start the debate with this question of determinism, and then they argue their way out of it, in a sense. And I see no reason to accept the premise of determinism just from physics. Right? So physics just hasn't proven, at least, that the universe is deterministic. And we know, from quantum physics that, two things. First of all, that the state of a system. Well, let me back up. So the normal view of physical determinism is the state of a system at time t plus the laws of physics completely determines the state of the system at time t+1. Right? However, the first bit there, the state of the system at time t, is only if that's exhaustively defined. Right? And so that's a really key point, because in fact in quantum physics says you can't exhaustively define the state of a system. And that's nothing to do with us. It's not a epistemological kind of question. It's that the system doesn't exist in a fully defined state because of the physical laws and the Heisenberg uncertainty principle and so on. And then even the next bit, that the laws of physics determine the outcome, again, quantum physics only does that probabilistically. So it'll give some probabilistic evolution of the system until there's some intervention or interaction that forces the famous collapse, and then one of the possibilities becomes actual, but apparently at random. Apparently really a random selection from that probability distribution. So if you run the thing, hundreds of times, you'll recover the probability distribution very exactly, but just on a single time, you'll get one random thing, and it doesn't seem to be anything else causing that, which is hard for people to accept. Right? Now, many people would say, well, okay, quantum physics is weird, but we know classical physics is deterministic, at least, right? So the quantum stuff, maybe through weird things like decoherence, doesn't affect what happens at the classical level. That is, there's some macroscopic emergence of states or emergent determinism, really, despite the underlying noisiness of what's happening down here, which is a weirdly non-reductive argument for people who are otherwise avowed reductionists to make. As it happens, classical physics isn't deterministic. It's just a myth. It's just a set of assumptions and idealizations that come, from Newton and his success with predicting the orbits of planets and stuff like that, which happen to be extremely obliging systems when it comes to predictability. But most systems are not like that. Most systems are much more complex. They're very sensitive. They have non-linearities. They're very sensitive to small changes in initial conditions. And in fact, again, you can't exhaustively define the state of a system, even at macroscopic levels, simply because the amount of information you can cram into any physical bit of the universe is finite. And in order to say that there's information of all possible future states of the system right here, right now, all that information would have to be crammed in there physically. At least there's a strong argument that that's a valid point of view, and there's certainly no evidence that it isn't. Okay. So what that means for me is that the classical physics, as well as quantum level, underdetermines the future. And it says that, first of all, you can't define a state at time t exhaustively. And secondly, partly because of that, when you have all these nonlinearities and so on in many systems, little differences here could make a massive difference here. So what they do is they open the future. Right? So I would say the future is radically open. And the further into the future you go, in a sense, the less constrained it is by current conditions. And actually, we know that, like, if you think about predicting the weather, we can predict the weather very well, excuse me, like 5 minutes from now, and pretty well a day from now, and so on. And a year from now, we can't predict it. And the argument here would be that that's not just because we don't know all the details. Like, if we knew and we had the big supercomputer, it would be predictable. No, it's that the universe doesn't know, right? There's no truth value to the statement, it will be raining a year from today, right? It's not either true or false, it's indefinite. And I think, so that view to me is just much more congruent with what physics actually says. And so starting with the premise of determinism, and either denying the phenomenology of our experience, which free will skeptics do, or tying yourself up in knots, which I think compatibilists do, trying to defend moral responsibility, which is really what they're defending. It's really what they say determinism is compatible with, is moral responsibility. The free will bit in the middle is just how you get to, it's like the kind of free will that can allow us to defend moral responsibility. So yeah, I see no point I see no reason to start on that turf. And sorry, let me just say just the final thing. I think if you start with the indeterminist view, then you have a different question to ask, right? Rather than where does the freedom come from, you have to ask where does the control come from, and that's a different kind of angle to take on the picture.
Yeah, I'd like to get some really interesting arguments there, and I would like to dig more into all of that. But just hang 1 second still on the categorization question. Which, sorry, philosophers are really irritating. I mean, ultimately, we're interested in what's true, but just hang in 1 second. So you seem to be saying, implying you're not a libertarian there, but I mean, I think I would say like the libertarian view just really holds two conditions, right? One is determinism and free will are incompatible, right? If big if, obviously, if the universe were determined, we wouldn't have free will. Secondly, we do have free will, right? And I just those two things. And I think you sign up to both of them,
Yeah.
don't you? Or...
Okay, well then, yeah, if that's if those are the broad kind of criteria, then I guess I would be a libertarian. I guess I don't self-identify that way, partly because I find
yeah,
the existing libertarian arguments unsatisfactory, and part of the reason for that is that they still kind of take a view of deterministic evolution of systems as the ground level, and then they sort of sprinkle in some randomness on top of that, right? And I just don't think that's a good way to think about it. I think instead the randomness is not some positive thing that enters the universe at certain points to push things one way when they would have otherwise gone a different way, right? When you do that, it's hard to find the causal power of the self in that situation, because it's like either things are deterministic or they're random, and in neither case is it obvious how you get causal power of the agent. Whereas if you take a view where there's this pervasive indefiniteness, it's just an underdetermination. It's not a positive thing that enters, it's a negative, right? We're just saying the future could go many ways. Many things could happen. Now the question is, how does an agent make happen out of this broad, I don't know if you can see this, out of this broad range of things that could happen, how does it make happen what it wants to happen, right? How does it narrow that to just this happening, right? Within a certain sort of range of what it cares about. So, I guess that's just in terms of the labels. I don't know what to label my position. I don't, but it doesn't quite
that's interesting.
Completely with what I take to be traditional libertarian positions.
So you got that maybe a difference with what you take to be often assumed by libertarians, that sort of determinism is generally true, and there's this weird exception, whereas you think that's the wrong starting. But I mean, also people often associate libertarianism with belief in the soul, but you know, I don't think there's anything I wouldn't want to reject out of hand substance dualist as a ridiculous position. It's not my position, but a lot of libertarians these days, like Helen Stewart, take themselves to be very naturalistic, think that agency is something pervasive in the animal world as well as just with humans and so on. But
Sorry, I was just saying I would align, I guess, pretty closely with Helen Stewart. So I think Helen's positions and mine are pretty close. We sort of emphasize different things, but I think we land in a pretty similar place. So if that's libertarian, that's libertarian, then I guess maybe I am. Like I said, I'm not really concerned with the labels that much.
Sure. Who cares about... previous guest on the show, Helen Stewart, if anyone wants to check out. Very interesting philosopher. And okay, well, we want to dig a bit more. That's sort of so much for outlining the position. Want to dig a bit more into this. So I'll hand over to Professor Frankish for some further analysis and discussion.
So, thanks, Ken. I think that's really interesting sense of where you're coming from. So you've told us all this story about the evolved mechanisms. Mechanisms in a sense, not just very sort of clunky computational mechanisms, very complex mechanisms that interact in all sorts of highly complicated ways. Mechanisms of self-control and action selection. When you've told us about how this evolved, and then you've also got this picture of the universe itself being inherently, the future being inherently open, undetermined. And so I mean, tell me if this is right. Tell me if I'm understanding you right here. So how these two things, these two factors, the mechanisms of control of the inherent indeterminacy of the future, how they work together to give us free will. Is the idea something like this, that what's happening in our brains is not at any particular moment is there's some indeterminacy in it. I'm not sure I quite see how this works, but things are maybe firing at random a little bit, and this is sort of suggesting different possibilities to us, different ways we could go, different choices we could make, or these little effects are being amplified into different choices that we could make, different courses of action that we could follow. And these are then being filtered and assessed by the mechanisms you've described, by the cognitive mechanisms you've described, and the little effects are being amplified through those, and then they're being compared and passed around in different parts of the brain. And these, in a, not exactly necessarily in a deterministic, but in a sort of more mechanical sort of way we can understand the processes of evaluation and so on. And that eventually, at some point, maybe another effect of randomness is to stop that process at a certain point and say, okay, that's enough. And then finally some action, determinate action issues from that. So there's a sort of random generation of ideas, a rational, hopefully rational process of assessment and filtering, and maybe some random point at which it stops and says that's enough, and then there's a determinate outcome, and then that's fixed. Is that roughly the picture? Or have I simplified too far?
Yeah, no, I mean, there's elements there that that are the way I would put it, and some that I would put it a little bit differently.
Mhm.
And what I wanted to do first actually is just say that the importance of the indeterminacy is more fundamentally than its actual current action in the brain right now, is that
Right.
it allows macroscopic causation to emerge at all. Right. So the idea is if the universe were fully deterministic at the lowest levels, that implies complete causal reductionism, to my mind. Okay, so it means that all of the causes are happening right down at the lowest level of the laws of physics, and there isn't any room, right, for any other causes to emerge there. In fact, there wouldn't be any reason really for functional macroscopic structures to emerge in that kind of a universe. The atoms would just be bouncing around and doing whatever they do, and things would just continue to happen, right? So what I want to do is, in the first place, is say actually the importance of the indeterminacy or indefiniteness at the lowest levels is that it means that causal reductionism doesn't have to hold, and that the way a system is organized can have an effect over how it evolves. And that's a very commonplace kind of view. It's really been very nicely articulated by Alicia Huarero and others, but I think her most prominently. And it's why our computers are working right now. The electrons in our computers are still obeying the laws of physics. They're just being constrained, and they're being constrained towards a function. And so this capacity for stuff like that to happen means that life could evolve, right? Because life has functionalities in it. The function is just to keep going, right? But little bits of functionality allow the organism to keep going better. And so you ultimately get these control systems that can emerge that are using the organization of the whole system to constrain how things evolve. Okay. So in a sense, you could say that in a current moment, you could have organisms that are using that control to make happen what they want to happen, right? And actually, you don't need indeterminacy right then and there in that sense. You could still, in order to defend the idea of control. Partly that's actually similar to Dan Dennett's position, right? But the difference is I see a way to get there, to get to that point. That's the difference in my mind, okay? However, having said that, it's also the case that we now have a problem, right? How does the organism control things? Because now there's this indefiniteness. Now that's a challenge for the organism. I mean, in a sense, it's a resource that it draws on. But in a broader sense, it's like all these things could happen, and it wants to make this happen, but it's got noisy components, right? So neurons are noisy. They're full of proteins. They're jiggling around the place. It's just not a very determinate thing. So really what the organism has to do is try to corral all of that to ensure that the systems are actually functioning and doing what it wants. And so that's the broad kind of point. And the sort of two-stage model of free will there we can come back to, but I wonder if you have any thoughts on just what I've said so far, because it's a slightly different question to the one that you raised. I just didn't answer your question. I would like to, but maybe I'll just leave it.
That's so much I could say here. And I feel that I feel frustratingly that I'm so close to you on some things. And look, one thing you talked about here, you talked about lower levels and higher levels, and I find that of causation, and I find that unhelpful, because it sounds like you've got the lower level things, the atoms, the ion channels opening, whatever, they're doing their thing for their ion channel reasons, whatever. Ion channels open because of, I don't know, gradients of ions on one side of them or something, whatever, for chemical reasons. And then you've got these sort of mysterious higher level causes, sort of organizational causes, that are somehow having some downward effect on this, and maybe stopping them opening or something when they would have opened otherwise. No, I think that's a really, and I'm not saying that is your view, but I think anyone who thinks that way, that's a really bad view, because it sort of pictures this level. It's as if they're all the workers at the bottom. Okay, it's like an organization. The workers at the bottom, they're doing all their things, and then there are higher levels of organization, and there's the executive at the top. And the threat of determinism is, as it were, that the workers are really doing everything, and the executive's just there for show. He's just sitting in his office, just enjoying the perks and not doing anything, and his commands don't get down to the workers. And so, and I think that's how this sort of worry that the physics is doing it all gets its grip, that the higher levels aren't sending any commands down there. But that's just, I think, a really wrong way to think about it. It's much more like there's just one level. There's just the workers. Ultimately, there's just the physical universe. And the workers are organized in all sorts of complex ways. Okay, and they're collaborating with each other. They've got, it's a workers' cooperative. Okay, so all the organization, that instead of being hierarchical, is just a matter of the workers getting together in different ways, and how they've got organized in that way. Well, we could imagine that there's the master who's organized, but we don't need that, because you've told us how they got organized. They got organized by natural selection to this way, and because whether how they performed was judged by the environment, and when they didn't perform well, they were reshuffled into different patterns of organization. So now there isn't now a competition between the causation from the workers and the causation from the organization. They're the same thing. The organization just is a bunch of workers doing their stuff, but now doing it in an organized way. So there's no extra cause. What there is an extra causal explanation. You need to cite the organization in order to of the workers, in order to explain how the system is functioning so effectively. And if you miss that, it would just seem like magic. So there's an extra causal explanation here that's come in through the organization, but there isn't some extra causal power, some extra force that's pushing the worker, individual worker around to do something other than what they're naturally disposed to do.
Yes. Okay.
If we could talk about new causal explanations, Emergent, I would be with you 100%. Talk about new causal powers, unless that's taken to be in just an explanatory sense, then I'm skeptical. Okay, so there's a thing to back at you.
Good. Okay, I think I understand what you're saying, and I disagree. You won't be surprised. So first of all, I think that the organization of the system does determine whether the ion channels will open or not, right? In a sense that but in a diachronic sense, right? So to understand the system, and living things, you just have to take a view through time, right? It just doesn't make sense. You're not going to get a grip on it in an instantaneous kind of view. Sorry, Philip, you're muted there.
I wanted to do the tech word buzzer that you said, diachronic, just for perhaps not all viewers will know what diachronic means across time as opposed to synchronic. at a time. Sorry to interrupt. Continue.
No, you're good. Thank you, Philip. I should have done it myself. Yeah, so living things are processes that have continuity through time, right? And so when we think about this whole top-down or whole part causation, one of the stumbling blocks that people often have is like, well, wait, the whole is made out of all the parts and they're constituting the whole. How can the way the whole is constituted be also causal into telling what the parts, telling the parts what to do? And so it feels like circular causation as a logical fallacy, right? But it's not circular, it's spiral causation through time, right?
Right.
So what happens is natural selection, as you said, is doing design work. Exactly the same sort, well, analogous to the design work that went into this computer, right? That we're communicating through.
Yep.
And that design work is constraining how the elements behave under different circumstances by embodying criteria for what should happen that are functional, that refer to things that, in this case, for living things, the organism cares about, right? So that's how its nervous system gets configured in such a way that it is remembering things, and it has criteria for action, and it has all sorts of top-down mechanisms as well that are in real time now. Things like attention, things like new goals coming, being chosen, that have causal power over lower parts of, or different parts of the brain, that are giving them a context which now changes their criteria for firing. So just in sort of empirical terms of how the brain works, that's just what happens, is that you do have a hierarchical kind of a system where there are these different sorts of elements happening. And I want to just say one other point that I think is really important here. So if we're saying all the causal work is really at the low level, which is effectively the reductionist view, which to my mind is kind of eliminative. It says, look, all that cognitive stuff is an epiphenomenon. What does it matter what you feel? What does it matter what those patterns mean to you? They're just physical things, and the physics is effectively going to play out, right? To me, that's what the view that you articulated kind of entails. But I don't think that's right, because what we can see is that, in fact, the causal sensitivity in the system inheres at the level of patterns of neurons firing that have a meaning for the organism, right? They're representations about something in the world, or about a current internal state or a goal or something like that. The way that populations of neurons talk to each other, sorry, let me get this one out, and I'll let you. The way that they talk to each other is that you'd have a population of neurons here that's monitoring the activity of a population of neurons here, and there are some criteria in the synaptic connections that say, when this pattern looks generally like A, do this, and when this pattern looks generally like B, do that. But the details down here don't matter that much, right? There's loads of microstates that all look like A to this population of neurons. Yeah. And loads of microstates that all look like B. It's only when there's a transition between those two patterns that this interpretive thing will happen. And so for me, it's right to say that the causal sensitivity is at a macro scale, and it's not an illusion of causal power. It's a genuine causal power that inheres at that level. So I would say the level thing for me is, I would claim it's absolutely real and has real causal relevance in the system.
You see, we're so close here, actually. But I mean, what you're articulating, I just hear that as kind of standard functionalism. There are functional patterns here, and those functional patterns, are causally salient, certainly, absolutely. And they're not type identical with physical patterns. Absolutely not. They're multiply realizable, as you say. But they are token identical with them. Each one of those patterns, each instance of that pattern, is identical with some arrangement of the lower level stuff. And it's identical with it. That means there's no question of it being epiphenomenal. I think not. It's the same thing.
Well, yes and no, I would say, but not really, right? In any moment, right? In any moment, some macrostate has to have a particular microstate instantiation, of course. So you could say, again, if you just take that moment, that you could say they're the same thing, right? In the sense that if you knew the whole microstate, you'd know the whole macrostate, right? However, in a counterfactual sense, we're thinking about causation, right? then you can do the counterfactual and say, well, let me change the microstate. If you think the microstate is what's doing the causal work, I'm going to change it. You know what happens? Nothing.
Yeah,
so this guy still thinks it's the same, right? Unless
it doesn't capture the causal pattern. It doesn't capture the causal explanation. I agree with that totally.
Yeah.
But there's no extra causal potency that the pattern, of this instance of the pattern has, that the complex arrangement of the complex this instance of the pattern gains its causal potency from the cumulative causal potency of the components.
Okay,
there's no sort of
there's a way to flip that, right? Yeah, so there's a way to flip that, which is to say that the microstate, any current microstate, only has causal power in the system by virtue of what it means, right?
Well, they're identical.
Of how it's
identical. So yeah, I mean,
yeah, I just would dispute the identity thing, but I think, like you said, we're very close. Maybe it's
let me just put one question to you, because this is so interesting, and I'm sorry, and I'm not letting Philip talk, and I will. Let me just put this one question to you. Do you think? Well, let's talk about the ion channels opening. You explain. I'll get the details on, but you explain how this happens and how this is crucial, because there are what is the gradient, the ATP, ADP?
Oh, well, the ion channels in the neurons, it's going to be potassium and sodium and calcium and chloride and so on.
And you explain how those open and close, and how that's very important to the energy. The energetic processes within the cell, how that provides the cell with its energy to do work. Okay. Do you think that aren't the conditions under which those channels open always local? It's the local environment of, you don't think that somehow stuff elsewhere in the brain, the global pattern of things elsewhere, they can somehow make this particular channel here open at this particular moment.
That's exactly what happens. Yeah. So first of all, let me say,
not mediated by anything local.
It is, but it's also mediated by more global things and by particular other neurotransmitters that set the criteria. So first of all, let me just make a distinction, because I think there's a couple places in the book where I'm talking about ion stuff. One is in like mitochondria, at the origin of life kind of stuff for generating energy. But the other is in neurons, which is ions flowing in and out of the membrane and effectively allowing electrical signals to be sent, right? Or determining the threshold of whether an electrical signal gets sent. Now, you'll have one neuron sitting there, it's got its ion channels, right? And it's getting some inputs from other neurons, and it's kind of summing them up, basically. Calcium flows in, and if it reaches a certain level, and it comes through all the sort of computations in the dendrites that gather that information, if it reaches a certain level, this guy will fire an action potential, which means the sodium channels will open up, and you'll get that electrical response. However, whether the ions open up or not, first of all, it depends on the particular pattern of inputs, but it also depends on things like neuromodulators. So other neurons, like that convey things like dopamine and serotonin signals, come in and they set what the level of what this neuron should pay attention to, right? So they may tune it up or down very, very quickly, and in response to things like top-down attention. So that changes the salience of particular signals. It changes the threshold, the electrical threshold of whether this neuron will fire or not by changing the electrical potential across the membrane. So it's exactly that kind of a top-down system that imposes, in that case, a particular signal. You can also get kind of global signals depending on what neighboring neurons are doing.
No, I absolutely.
Exactly that allows neurons to, allows the whole system, in a sense, to figure out what to do as a global collective. And I think this is so important because
I agree with that. I absolutely agree with that. And you explain this. You explain these global effects beautifully. But I think let me put it like this: does anything happen in the cell that isn't explicable in neurochemical terms, in the kind of terms that you're, as a neuroscientist, are interested in? Does anything happen there that can't be explained in those terms, apart from, say, just randomness?
There's no magic in the cells, right? I mean, so it's all of course going to boil down to some physical mechanisms that we can understand well. The question is, when you say explicable, is that the right level to do the explanation for the phenomenon we want to explain? And I would say,
when we talk about higher levels of explanation, I'm absolutely with you. I'm 100% with you. It's the idea of there being sort of emergent causal powers that are not explicable in terms of what the cells are doing and the connections between the cells and the neural model, and all this stuff that you talk about so beautifully.
So this gets at a really important point. So some people would say, moving on from kind of physical determinism, that we just have a sort of a neural determinism, or even a neural sort of reductive power, where all the work is being done in the neurons, right? And part of that view is actually it's not just going down from cognition to the neural level. Sorry, Philip, did you want to come in?
No. I'm going to take over from Keith at some point in the future.
Yeah, absolutely.
But you carry on, Kevin. I was just indicating to Keith.
Yeah.
No, I've got it. Yeah.
That's great.
It's probably
part of it is to go from the psychological level down to the neural level. But there's another kind of reductionism at play there, which is to say it's not your whole brain that's making things happen. It's this little bit, right? It's this, you did such and such because this circuit in your brain fired. So it's an isolation. It's a sort of a decomposition of this big holistic engine into little parts where people would say, oh, you ran away because your amygdala was active.
Oh, yeah, I'm totally with you on that.
Yeah, so it's a very common position, though, and that's the position that I was mentioning at the start. That neuroscience is giving this. It's not just that it's reductive; it's that it's isolationist.
I'm totally with you, and you make a fantastic case for that in the book, and I've nothing but wholehearted support for that.
Okay, great.
We're so close, but there are other anyway. But I could go on, but it's time for Philip to come in and press you on.
I do want to press other things, but just on this. So yeah, Keith, you're always trying to say, "Oh, we just got to save you," really, but I don't know. I think Kevin is saying something very different from your view. I think, if I'm understanding you, Kevin, right, that it is that it's not just what's at the micro level that's running the show, that there is genuine new causal potency at these higher levels that is making a difference. That is, I don't know. And
that's absolutely right, Philip. Yes, it's not. I'm absolutely defending the view of macroscopic, emergent, a whole system sort of causation, which is why I think it's possible to defend the view of agent causation, that something happened because the agent made it happen, even though of course it used its bits to do that, right? But it's not the bits making it happen. It's not being pushed around by its parts. The causation happens at the agent level for agent level reasons, right? Not for part level reasons, and for agent level meaning. Those patterns mean something to the organism, not to its bits, and for agent level evolutionary reasons, even in terms of the fitness of the organism being the thing that is that the functionality is supporting.
But maybe I could just put it this way, Keith. Just before you come in, Keith. Just before you come in, here's the point, right? Look, Sean Carroll would say, yes, there's kinds of explanation at the higher level that are more helpful, that are more, involving agents and things that understand. You can't understand that in terms of in terms of particles or whatever, but in terms of what's running the show, it's at the micro level. I think Keith's trying to interpret you as having that position.
I don't.
And when you say, okay, there's agent reasons, I think Keith's hearing that in the Sean Carroll way. Yeah, there's kinds of irreducible explanation. But you're saying, I think you're saying, and this is the last point I'll make on this, and I think you're saying more than that. You're saying, no, it's not just irreducible kinds of explanation that are, it's that there's new causal potency at the higher levels. Yeah,
exactly. That's exactly the point, Philip. And so Sean Carroll has this view that I find weirdly contradictory, and it feels like there's a tension when he's talking about it, because he'll talk about this idea of affective theories at different levels and how they're the right level of explanation up here for complicated systems, even like for societies and economics and so on. It doesn't make any sense to talk about economics in terms of quantum fields, right? And that which I agree with him, and yet it's almost this sort of like it's just convenient to talk about that up there, but he reserves the idea that, but actually all the causation's down here, because he says things like the low-level physics is causally comprehensive. And not only that we don't know of any other causes, that the system that we have, the theory that we have, does not admit of any other causes. No other causes.
Which is what Keith thinks as well.
But it doesn't need to admit of other causes, because the other causes, of course, that's compatible with there being other causes, because the other causes are simply aggregates of the you've got to take the identity theory seriously.
That's not
two things here. One of which is doing the cause, and the other which is just a sort of phenomenon. It's the same thing. No, so you could equally say that's the real causation. Is this the real causation or that? It's the same thing. There's no question of there being.
There is, of course, an instantiation, right, in some physical stuff, right? But the details of that often don't matter, and in the brain they're often arbitrary and incidental. And so, for example, again, if we go back to the computer, if you want to say that all the causation is just in terms of electrons flowing around the place, then I would say, well, no, that's not right, because the way the electrons are flowing around is constrained by not just the hardware, right, and the design that's gone into the hardware, but the particular program that's running right now is constraining what's happening there without violating the laws of physics. And it adds genuine extra causation, which is admitted precisely because the underlying physical universe is not causally comprehensive, because it underdetermines what will happen in the future, and that introduces some causal slack in the system that allows the organization to come into play. And if it didn't, right, if that didn't exist, you would never have macroscopic structures to be having this debate about in the first place.
No, that's another thing I would disagree about, because
Keith,
compatibilism doesn't have to be. Let me just say this, because it will actually focus the
last word.
No, but this is to focus your objective difference with. I think that, let me put it this way, because I think this will capture what I think is a difference between you, Philip, and Kevin. But let's see it. Is what happens at the cellular level explicable entirely in terms of if it's dealing with neurons, neurochemical, electrochemical processes within the cell and within the surrounding environment within the brain, explicable at that level? Do ion channels open for reasons that have nothing to do with neuromodulators?
Nothing to do is too strong, right, Keith?
Yeah. Well, let me make this as a concrete scenario. Imagine you've got two situations where in one situation a neuron gets some signals and it fires, and in another situation it gets the same signals and it doesn't fire, right? You want to say, what's the explanation for what's happening there? What's the explanation for that difference? The explanation could be, I thought about something and that sent a signal that changed the sensitivity of that system by opening some ion channels that change the electrical potential and so on. Of course, there's a mechanistic explanation, but the real reason why the neuron fired in one case and not the other is because my attention was directed to something, and I had a thought about something else, and I had a goal. So it's the meaning. I would say it's the meaning that drives that mechanism.
There's a sense in which I could agree.
I think that is
can
an
you see that there's a sense of reading? There's a sense of reading that in which it sounds like psychokinesis. I'm not. That's not the sense you mean. But can you see that there's a sense someone could hear that and think you're talking about psychokinesis?
Absolutely. So let me say
that's the sense Philip means.
Perfect.
That's the sense Philip means.
I know, Philip, you want to get in. Can I just respond to this one?
That is not a fair way to say I believe in psychokinesis. Right, we really have to. What is going on?
I'm going to shut up.
I know what we've been doing. Actually, Keith and I have been having an argument about how to interpret Kevin Mitchell's work, even though he's sat right here. So it's a really kind of bizarre. But anyway, yeah, I think we're. Move on from this in a sec, because I want to press Kevin on other stuff. But let's let people can read Kevin's book for themselves and decide whether my interpretation
excellent idea. I recommend everyone to do it.
Is the correct one. But Kevin, go on. You have the last word on this topic, and then I'll
Yeah.
ask you some questions about something slightly different.
I mean, what Keith just hinted at there is this problem of mental causation, really. So how can it be that me having a thought where it's the content of the thought, it's the meaning of the thought for me, that has causal power in the system? And it feels like when we think of thoughts, they're these immaterial things, right? But what I would say is no, thoughts are not immaterial. They are instantiated by patterns of neural firing. Now, you would say, yes, that's exactly what I've been saying. It's patterns of neural firing that are doing the work. And I would say, no, it's the thought is a meaningful pattern of neural firing, right? And it's the meaning that is doing a lot of the causal work, in the system. Of course, it has to have a mechanism that is allowing it to do that. But it's the meaning that configures the system both through time and very much in real time as we're thinking about things. So a thought can push neurons around because a thought is a meaningful pattern of neurons firing, and neurons firing pushes other neurons firing around, right? So to me, you can have a physical causation that allows that it's the semantic content that is the important causal element in it, in an irreducible way. That's what I would say.
Okay, great. We need to move on. So I'd like to ask you about something slightly different for 15 minutes or so, and then we'll have some audience questions. So people are asking things. If you want to save that just for a moment, so just sort of probe more this really interesting idea of the indeterminacy in quantum mechanics creating causal slack, which then agents make use of, exploiting their free choices. And as you say, it goes back to what's his name, ancient Greek chap,
Epicurus.
Kevin, who's it? Epicurus with his swerve, right?
Swerve.
That we need.
Wonderful swerve, yeah.
Yeah, very cool, very cool. It's nice to be rediscovering this Epicurean project, but in modern scientific way. So is the idea? I mean, can we just get a concrete example? If like Bob's making a free choice whether to cheat on his partner or not, is it the idea so that like the quantum mechanical indeterminacy, leave it open whether he's going to cheat or whether he's not going to cheat, and then higher level processes settle what the quantum level leaves open? Is that the idea?
Not well, somewhat. So what I would say is that what the agent wants to do is control what happens, as I said, and so it does that by corralling like things like the firing of neurons and the opening of ion channels and so on, to the degree that it needs to make happen what it wants to happen in the world, to the degree that it cares about. Right, so it doesn't care about the micro details. I mean, I could take a drink of water now, and I could do it with my left hand or my right hand, and the muscles could move in some way or another. I don't care, right? I'm not deciding that. I'm actually choosing a future. I'm choosing a future in which I have had a drink of water, right? The action is just the mechanism whereby I make that occur. So in a sense, what happens, I think, is that in many scenarios that we encounter, we have strong reasons to do one particular thing, right? It may be completely habitual. We may not even need to think about it. So in many scenarios, we've done the thinking already, right? We've done the work in prior times. We have experience that says, you know what, this is a good thing to do. And we can kind of offload that to effectively subconscious automatic kind of systems. In other scenarios, there may be a multiple choices. We may not know exactly what to do. And in that kind of scenario, I think we have some systems that suggest some possibilities. Now, what's important there is that it can't be an infinite array of things that are suggested, right? It has to be constrained somehow, again, by kind of, you think, subconscious habits of thought, right? Not habits of action, just ways of thinking about things where things get suggested to you. And then in this two-stage model, they get subjected to an evaluative process where the brain systems effectively simulate what the outcome would be of these various actions, and they weight the predicted utility of those things relative to current goals and ongoing agendas and plans and all the rest of those things. And then there's a kind of a competition between them, and the weighting up votes one and down votes another, and eventually, after some rounds of kind of this competition, one of those actions is selected, and all of the others are suppressed, right? So a lot of our action, in fact, our action selection system mostly is stopping us from doing everything else, right? All the time, and releasing one action that we think is a good one to do in a certain circumstance. So in that initial suggestion of possibilities, there seems to be some randomness at play. What's really interesting is that that is a resource that we can draw on, because in some circumstances we may find that of those options that we considered, and we chose one, maybe it didn't work out so well, so we try another one, it still doesn't work out, and we exhaust that range of possibilities, and we're totally frustrated, right? We're not achieving our goals. There's systems in the brain that involve things like noradrenaline coming from the brainstem, which in effect raise the temperature of these neural networks, that kind of shake them out of the most habitual patterns that they tend to fall into, and allow new patterns to emerge where the search space is kind of expanded. So it's a sort of a neural mechanism for creative thinking and problem solving under sort of frustrated circumstances. And it's one that that there's a fair bit known about, and other organisms have similar kinds of mechanisms where they draw on randomness as a resource. Now, sorry, I don't want to say draw on randomness. I want to say allow more noisiness, right? So the neurons are noisy. Ordinarily, they're collectively being, constraining all of each other to certain patterns, but that collective constraint can be relaxed. Right, so you're not adding randomness. You're just taking your foot off the thing that corrals it, right? So you're allowing the noisiness to have a little more play in the system, and then you still do the evaluation yourself. So this goes back to William James's two-stage theory, where he said ideas come to us freely, and actions go from us willfully. And so I think that's a nice kind of explanation that fits in my mind, where there's some, it's not predetermined what we're going to do, and yet the outcome is not random. It's not driven by the randomness. We're still having some say in making the choice.
Yeah, I'm a huge fan of William James, and it's great the way you're taking these old ideas and presenting them in this sort of new scientific context. But just so, I think the thing I'm a bit stuck on, I think we've maybe discussed this on Twitter a while back, but the quantum indeterminacy, it's not just a free for it doesn't just leave all the options open. It's a sort of probability distribution, right? It says the Born rule tells us there's a certain probability this will happen, a certain probability as well. So the situation we might really be looking at, I mean, I don't know what the hell the probabilities are, I'm not a physicist, but let's say the quantum level might give a sort of 70% chance Bob's going to cheat on his partner, 30% chance Bob won't. So it gives you these kind of objective probabilities, at least in the indeterministic interpretation of quantum mechanics. So how does that figure in the view? Does that factor out as a sort of Bob having a pressure to do one rather than the other? Or
I would say that it's just a mistake with respect to translate what's happening at the quantum mechanics level to the level of those kinds of high-level actions and motivations that inform the actions, right? So what I would say is that it's not that individual quantum events are determining a high-level action like that. It's just that there's some noisiness, right? And it's quantum, it could be thermal fluctuations, it can be noisiness at the classical level. It doesn't really matter at some point. It's just that the physical state of the system, the brain, is not predetermined by its current state, right? So the next state is just not predetermined by the physics of the current state. And what that allows is this macroscopic functionality to emerge where it embodies the meaning of states. And what it means is cognition is real, right? When we're operating over cognitive objects and we're talking about goals and beliefs and desires and levels of certainty in beliefs and levels of urgency for motivations and all those different elements of cognition, that's really what's happening. That's the right causal level. And the quantum indeterminacy, the classical indeterminacy, is just what allows that system to come into being for the most part. Now, I mean, what we just talked about, this two-stage model, I was saying there is also some ability to use that noisiness as a resource. And for example, many animals do this when they want to escape a predator. And it's good to do something at random, because being predictable means your lunch, right? So, but also we can do it when we don't really care. Like a lot of times, I was talking about situations where we have good reasons to do A or B, but in many cases it was like, I could do A, I could do B, I don't really care. Why should I bother? Like, I just should do something. And so there are systems that can break that deadlock. And I think one of the important kind of lessons in this discussion is that we shouldn't just think about one type of scenario. There's just tons of types of scenarios, right? And our decision-making systems are able to deal with ones where we have strong reasons. They're able to deal with ones where we don't really care that much. And they're able to deal with ones where we're really stumped about what to do, and we need to cognitively explore, think of new things, or just decide to get more information before we make an action in the world that commits us to something in an uncertain, kind of unpredictable scenario.
Yeah, good. That's very interesting. So I suppose what I'm building up to an argument here, and I guess it goes like about how I guess I'm not convinced that the indeterminacy of quantum mechanics helps really. And here's the argument, and you can tell me what you think. So yeah, quantum mechanics via the Born rule gives us a probability distribution. Let's say, just for the sake of discussion, it tells us there's a 70% chance Bob's going to cheat, right? And then it gives us a probability distribution about where the particles are going to be.
That's what it gives us.
And one of
that's all it gives us.
Okay. I'll give you the argument, and you can tell me what you think. So let's just say the 70% chance of the probability of 70% chance of the particles being here corresponds to Bob cheating. The 30% chance of the particles being here corresponds to him deciding not to cheat. Obviously, the probability is going to be much more complicated than that, but just to give us a simple example. And that what that means is, if the Born rule is totally right and totally, is all what's fixing what's going on here, then if you took 1 million Bob's duplicates in exactly the same scenario, 70% of them would cheat, 30% of them wouldn't, right? So in other words, although the quantum indeterminacy, although the quantum stuff isn't giving us exactly what's going to happen, it's giving us these objective probabilities. Now, if there are the free choices of agents, then they're going to mess with those probabilities. So if we took 1 million Bobs, it's not going to be the case that 70% of them will cheat and 30% won't, because there's all the higher level stuff messing with those probabilities. And that seems to me as much an infringement of physics as if physics was deterministic, right? So it seems to me like I just finish that point. Like, it's in other words, you've got to sort of grasp the nettle. If you either you say, like, physics isn't running the show, the equations of physics are not totally fixing what's going on, or you don't. And whether that's because physics is deterministic, potentially deterministic, but then there's other things going on, or whether it's because physics gives you these objective probabilities, I don't see that making a difference. I mean, in a way, determinism is just given an objective probability of 1. So whether physics is deterministic or indeterministic just seems to me irrelevant. The question is, for someone like a libertarian, is it physics running the show, or is something else going on? I don't see why it makes a difference if there's indeterminacy or not in physics.
Okay, so
over to you.
So, I mean, I think we've probably been through the arguments for why I think some indeterminacy or some indefiniteness is required to enable macroscopic functionalities to emerge at all. So I won't go over that again. But the scenario that you describe is what I think you can call the messing with model, right? Where it's like the high level decisions that someone is making is somehow messing with the probabilities of quantum events down at the low level. And that's not at all the model that I'm suggesting. What I'm suggesting is also, so there's another way to think about it, which is a filtering model, which is more like the 2-stage kind of thing, which is like, if things go one way or the other, they're filtered by the higher level design in such a way that it's the higher level design that's still doing the causal work. But there's another way to think about it, which is just the taking advantage of model, right? It just takes advantage of this indeterminacy, this looseness, right? Epicurus actually called it, well, I don't know what it is in the Greek, but loosening the treaties of fate, which I think is a lovely way of putting it. And in fact, he was one of the first ones who took that libertarian view, which is to make the argument from the observation of free will that determinism must not be true, which I think is actually just as reasonable an argument as to go the opposite direction. But interestingly, he also made the observation that if this low-level determinism were true, that you wouldn't get macroscopic functional structures emerging, right? So it was a really key insight in my mind that says that you know what, if you had a deterministic universe and you just played it out and it was all low-level kind of stuff happening, and maybe the quantum stuff says, okay, when we have a quantum collapse, it goes one way or another. Well, actually, no. Let's not say that. Okay, let's imagine there's no indeterminacy at all. Then things will just trundle along. You won't get any interesting functional structures emerging in that kind of a scenario. Now, I haven't developed that argument at length, but many other people make that. George Ellis, for example, a physicist and philosopher, makes that argument really nicely. In fact, you could say that even right at the cosmic inflation, if you didn't have some quantum fluctuations and things happening, you'd never even get the inhomogeneities that lead to galaxies and planets and things arising. So you need some indeterminacy for macroscopic structures to emerge, because otherwise you don't even get any uneven distribution of forces and matter. So anyway, sorry, I got a little bit far away from where we started on that one, Philip. Sorry.
Yeah, I just don't see it. I think I definitely disagree on this. I just can't see an alternative to. So messing with physics puts it a bit in a loaded way, but I suppose we could put it that way. Like shut up. The question is, like, if it was just physics running the show, if physics is deterministic, then you know exactly what's going to happen. Or if physics is probabilistic, then you get the objective probabilities that's going to happen. But that's what would happen if it was just physics running the show. But then on an emergentist or a strong emergentist position, well, it's not just physics running the show. That's what would happen if we just left physics to its devices, either on the deterministic or probabilistic phase. But there's this other factors that, if you like, mess with it or supplement it, and things go differently to how they would have gone if it was just physics running the show. So it's having that additional determination of what's happening. Yeah. Now, whether physics is deterministic and it's interfering with, it's messing with or supplementing that deterministic story, or whether physics gives us these objective probabilities and it's messing with those. Yeah, I don't see.
So
and we're not connecting somehow, and I just can't see how. It helps. It helps us to be able to mess with things if it's objective probabilities rather than a probability of one, i.e. determinism. Well, you're still messing with what would have happened if it was just physics running the show in either case. And I can't see an important difference.
If there are probabilities, right, and one thing can happen, and that whether that one thing happens on one occasion is random. It's a random draw from that probability distribution. It's not wildly unconstrained, right? There's a probability distribution. One of those things will happen, and what happens is really random at the quantum level. There's separate arguments at classical levels, right? This doesn't hinge on the quantum stuff, but just to follow that line of thinking, one thing will happen at random. So in a given present, many things may happen in the future, right? So in a complicated system that got lots of quantum stuff with all these probability distributions, each of them will have multiple ways that it could go, and left to its own devices on any given run, as it were, it could go over here or it could go over there, right? It could go, the future is open. That's the point. Many, many things could happen. Now we can ask, can another kind of cause come into play here, which is constraining the way that things are going in such a way that only this thing happens, or a smaller range of possibilities happens, right? And I think that can emerge without changing the quantum collapse sort of thing. You just don't have to intervene at that level because you don't care, right? It's because you only care. Maybe this is the point. You're not trying to make electrons go here or there, right? You're not trying to make photons go here or there or whatever. You're trying to make something macroscopic happen. And you can do that at the macroscopic level by constraining the system without having to mess with the details. That's the whole point of what organisms are trying to do at the level that they care about, because they don't care about the micro details and they can't influence the micro details any more than the attentional signals that I was talking about earlier can actually determine where individual sodium ions go, right? They don't. But what they do determine is statistically how many sodium ions will likely be brought into the neuron, because these are the settings of the ion channels and this is the electrical potential and so on. So you've got real macroscopic causation that doesn't have to mess with the quantum level stuff or the atomic level stuff, because it's operating at this sort of macroscopic, more statistical emergent level. That's the argument that I would make. Although I feel the weight of your argument, Philip. That's the best counter. That's the best counter that I can give.
Oh, good. Right. Okay. So what I'll do, I'll have one last go at this, then you can have the last word, Kevin. But while that's happening, if people want to put up questions, I know people have been asking questions, but I've lost track of them in the chat. So if you just want to put Q in the chat and then ask your question, and then we'll have 5 or 10 minutes of questions. Okay, I'll have one last go at this. So yeah, I mean, while people are formulating questions, so I agree. I'm not bothered about where the electrons are. That's when I'm making a choice whether to cheat on my partner or not, which of course I would never do. Just to be clear,
you're bringing it up an awful lot, Philip. I have to say that scenario seems to be on your mind.
I shouldn't. It's the obvious moral choice, I suppose. Yeah, what should I have done? Whether to have cheese or struggling with veganism. That's my moral dilemma I face most often. I'm not a vegan, but I try to be largely vegan. Anyway, yeah, I know I'm not bothered about where the electrons are, but there's a connection here, right? Where the electrons are surely corresponds to what happens, right? If I decide to eat the cheese, moving on to this direction, then my electrons are going to be in one position. If I don't eat the cheese, they'll be in a different position. And if, I mean, the Born rule gives us the probability distribution of exactly where the particles are going to be. So it does seem to me, if you're going to have this strong emergentism, new causal potency, you've got to mess with the physics in a sense. Keith mockingly calls it telekinesis. I think that's a loaded word. That's not what it is, because that's like, making things rise far away from you or something. But you're going to have to mess with the physics, and whether you're messing with the objective probabilities the physics produces, or whether it's just physics just gives you one option and you mess with that, I just can't see the difference. But anyway, you have the last word, and then we'll have some questions.
Okay. Good. So when we're thinking about a system that evolves deterministically, what we're saying is that given certain initial conditions plus the laws of physics, that predicts the next state, because physics will do what physics will do, right? And I know that you're at the quantum level, you're saying because the Born rule gives us these objective probabilities, and actually the Schrodinger equation evolves deterministically through time until a kind of a collapse event happens, that you see that as equivalent to a deterministic. I don't, because I think the collapse function is really has some randomness in it. So, but in any case, the important point is, how do you mess with what happens in the system? Change the initial conditions, right? You don't mess with this stuff. That's how it works, right? So you're changing the organization of the system. When it's organized like this, it may evolve like that. When you change the conditions, say like with a neuromodulator that signals attention, you're changing the conditions of the system, the way it's set up and configured in such a way that its evolution will now be different or have different criteria. So that, I hope, is you don't mess with the play of it, you mess with the conditions. Does that make sense?
Could I
I
just have
well,
one quick
I
word?
think we could
One
go on
quick
and
word?
on. It's a good point.
Can I have a
Okay,
quick word?
Keith,
I've been very good.
one last point, and then
I've been
Kevin can
very
respond,
good.
and then we'll have questions.
I do feel
Not sure about that.
that Kevin is has some intuitions. I should say I'm quite happy with it being within determinism. I don't know. That's for physicists. The compatibilist merely claims that if determinism were true, it wouldn't matter really, because everything's at a much coarser grain. And I think maybe Kevin had some sort of, I would say, hangover sort of intuitions about what has an interpretation of determinism, which of the consequences of determinism, which is, I think, too rigid. And this is something that Dennett's great on in his elbow room. But can I just ask Kevin one question? I just want to ask a question. We know about Laplace's demon, who knew about all the positions of everything, all the particles, everything, right at the beginning of the universe, and knew all the rules of physics as to how they would unfold. Let's imagine a kind of super Laplace's demon. Oh, well, God. Okay, God knows everything, right? God's, okay, so God knows the initial conditions of the universe. He knows all the physical laws and everything, and he also knows how every a random quantum event will turn out. He knows whenever there's going to be, he can tell when there will be some sort of the collapse of the wave function or whatever we're talking about, some quantum event, and he knows in advance how it will turn out, which way it will go. So nothing is really random. I mean, he's God, right? Okay, so nothing's hidden from him. We can imagine this, right? So now, will he ever be surprised at what happens when he's watching it unfold, or will he be able to predict? Will it be sort of super deterministic in that sense, that if you also have the answers to all the questions of how the indeterminate events turn out, would it then be predictable in to someone with the unimaginably huge computational
good way
power?
of posing the question.
Yeah. So I think Philip wants to say no. I want to say yes. And what do you want to say, Kevin?
Well, so it's a really interesting question. I think there's some problems with the Laplace's demon view, not just from quantum stuff, but from classical stuff, which is based on this limit of the amount of information that you can actually put into the universe at any time, right?
That's why it's gone.
So in fact, it's physically impossible to cram all of the information about all the future states of the universe into it right now at any point, particularly because it's expanding. So actually, as it's expanding, the possibility space is increasing. And now the equilibration of the physical systems lags behind, creating a gap between the systems the states that it could be in and the states that it's actually in. So in fact, information is increasing as the universe is expanding, which really sort of puts to bed, I think, the idea of predicting everything from here when the space of possibilities doesn't even yet exist. But what's really interesting is there's an analogy here with thinking about numbers and thinking about this infinite precision. So classical mechanics has this idea that it's deterministic, that's based on an assumption or an idealization, which is that the numbers that describe a physical system can be given with infinite precision all at once. So all of the numbers, all of the decimal places forever and ever are infinitely precise. And those precise, and they have values that exist right now, all the way to forever, basically. And that is the thing that violates the information limit, if you will, about how, like, it's physically impossible for that to be true, right? So that's an idealization that is quite explicit, right? It's not like I'm not discovered that's very overt in physics, and even people like David Hilbert, who was the champion of this kind of view, knew that it was only a mathematical device. It allows mathematics to go on because you need to use the concept of infinity and so on. But he knew infinity has no physical reality, right? Nothing could have that infinite information. So another way to think about that, well, there's two ways to think about it. Either, so these far digits of these numbers are the things that are going to affect farther future events, evolution of the system, right? Those are the ones that will affect the weather next year, where it's the close digits will affect the weather tomorrow. So there's two ways to think about it. Either they have no truth value and they're evolving randomly through time, or they do have truth values, but they were set randomly at the start either way, it's still randomness. You're just piling all the randomness into the initial conditions. And therefore, that's the scenario that you would say, God knows all. He's just waiting, right? It's already been decided what's going to happen. It's already been decided in the Born rule whether it's going to go the 70% or the 30% thing. And God is just waiting for those things to be revealed. But in essence, what that would require is that all the numbers of the system are infinitely piled into these initial conditions, and that they were in effect random.
Let me just quickly put it slightly more tractable.
We really need to move on to questions.
Just one quick. God knows everything about this.
Can this definitely be the last point? I'm going to mute you.
This particular time slice of the universe, he knows everything about the position of every subatomic particle in the let's just say on Earth, for the local environment. And he also knows how all the indeterminacies will pan out. All the things that are indeterminate, he knows which way they will go. Can you tell what I will do?
I mean, it's just a fantastical scenario, right? So that's a physically impossible thing to happen. So whether you want to imagine a fantastical being that knows that, it doesn't. I don't find it super helpful to entertain this scenario, frankly.
Okay. Yeah. All right. Okay.
Beyond a certain point, anyway.
Okay, let's move on to questions. Actually, just a point of interest. I spoke to Lee Cronin recently for something I was writing for Scientific American that I spoke to you as well about, Kevin, and he gave a similar rejection of the Laplace's demon thought experiment. But anyway, so there's interesting discussions there about whether we can make sense of that. Okay, we'll have 5 to 10 minutes of questions if we still have time. So starting off, I'm just going in the order they've come up. We've got from Space Guy here, a more sort of a priori philosophical argument against free will. So he says, or she says, if you believe in free will, you believe that at least some of your thoughts and desires determine the choices you make, and that those thoughts and desires are chosen by you. But that's circular. And that means you can't even have free will because free will is a contradiction in terms. Any thoughts on that, Kevin?
Yeah, that's a great question. And it gets to a point that was made by Arthur Schopenhauer and more recently by people like Sam Harris and Robert Sapolsky, that we can do what we want, but we can't choose what we want. Right? So our intentions in that case are formed by all of these sort of prior causes. Right? So at any moment, the way Sapolsky would describe this is that at any moment, all of the prior events that have led to your existence right now and the way your brain is configured right now, which includes evolution and your genetics and the way your brain developed and the experiences that have happened to you, and I want to phrase it explicitly in that way, that have happened to you, have all led up to your brain being configured in such a way such that when you encounter a given situation, you may do the mechanisms of decision making and cognition, but the outcome is in a sense predetermined. There's always just one possible outcome, and the machine is going to spit it out. Right? So it's a very algorithmic stimulus response, complicated, right? Really complicated, but still a stimulus response machine that's actually deterministic. And so there's no wiggle room in there. That's this view of you being pushed around by your parts. So your intentions are just things that make you act, and you have no role in choosing your intentions, which I just think is just wrong in terms of cognition. That it just couldn't be the case that the outcome of those cognitive processes could be so deterministic, given how complicated they are, and given the noisiness of the systems, and given the indeterminacy of the components and so on. So in fact, that argument reduces to physical predeterminism. That's the only thing that could actually support that kind of a view. And I would rather say that when we assess a situation, we really think about what we want to do, and our intentions are the outcome of that process. They're not the inputs to the process. They are the outcomes, right? That we talked about all the evaluative procedures and so on, processes that we use based on what we want, based on our reasons, real agent level reasons, based on our beliefs and desires, of course, right? It's not this idea of unfettered absolutist free will where we just act at random, which would be totally useless. The whole point of the historicity of life, and your klaxon can go off again. But the historicity is the idea that the complex systems, especially living ones, incorporate aspects of their history as they go along in such a way that they can use that information in an adaptive fashion to to predict the future and plan actions better, right? So that just is an organism deciding what to do for its own reasons and coming to its intentions through those processes, not being driven by predetermined, prestatable intentions in every imaginable scenario it could ever encounter.
Brilliant. Thank you very much. Okay, maybe we'll get a couple more in. Anon X, who's a regular member of our audience. Thank you very much for joining us. I think it's great, seeing as we're starting a bit earlier. I guess for the people in the US, it's very early. So it's great we've got up to our normal audience levels. Okay, without free will, it seems like any motivation for hatred disappears because a quote-unquote evil person who kills someone is no more evil than a bear or storm that kills someone. Is free will worth saving? Great question about the value of free will there. What do you think?
Well, first of all, I don't know if they're looking for a motivation for hatred here or not in the question. Which that's a whole.
I think it's isn't it better without free will? Why do you care about it? It's better for society if we don't have free will. It's better we don't blame people, we don't hate people, we all love each other.
Sure. So that's actually the argument, the motivating argument that Sapolsky brings to bear here, where his whole point is that we shouldn't judge each other for anything that we do, and there should be no notions of praise or blame or reward or particularly punishment. And so there's a whole sort of extra bits of thinking about moral responsibility and just our cultural, legal, societal sort of and interpersonal mechanisms of thinking about what other people are doing and what we're doing and whether it's a good thing or not, and all the sort of pro-social, anti-social forces that go into that. Right? So if it's a question of blame and responsibility, and people want to say it would be better if no one was held responsible for anything, I guess what I would say is if you do away with responsibility, you also do away with rights. You're doing away with autonomy. You're doing away with ideas of competence and consent and character and selfhood. Like, what does it mean to be an agent where there's no real agent causality at play? Then you just wouldn't be a person. I think it undermines the very concept of personhood to take away any sort of free will and the responsibility that comes along with it.
Okay, we have a question, maybe one or two more. No, you're cutting out a bit, Kevin. I don't know whether it's for everyone's having that or for me, cut out a little bit anyway. But let's carry on. Katka Slutova, who's another regular member of our audience, great contribution, says, how does mental causation work in your theory for different brain lesions or syndromes? If I misunderstood something, I apologize in advance.
No, it's a super question. So, it gets back to this idea of like, why do we care about free will? And in particular, why do we care about a science of it, right? I mean, we can have these sort of philosophical discussions, but it matters, right? It matters that we have a science of free will and a science of agency where when we're thinking about the way people act, we can have a kind of a handle on what's different when people have a brain lesion or when they have a psychiatric syndrome or when they have drug addiction or something like that, where we can think about what's happening in those systems without just always reducing it to mechanistic levels, where of course there are mechanistic things going on, and the fact that these kinds of effects arise shows us that it's not a magical, non-physical kind of a thing, that free will is an evolved biological capacity. And here I'm saying free will just in terms of rational cognitive control, what psychologists and neurologists call executive function. And we can think about executive function. We can think about the brain systems that mediate concepts of selfhood and self-monitoring and all of those things that go wrong in schizophrenia, for example. So to me, having that science there is essential. And if we don't, if we think free will doesn't exist, that no one has any control of their actions, then what contrast are we noticing when we compare someone who's addicted to drugs and someone who isn't, or someone who has dementia and someone who doesn't? What are we noticing in the difference there in their capacities for control if nobody ever has any control? It just seems a weird thing. So I think, I think grounding the the philosophical view on scientific terms gives us a way to approach these kinds of questions without dismissing the humanity of the people involved and the mental, real psychological aspects, without just reducing it to saying, you know what, you've got a deficit, your machine's not working right, and I'm going to, necessarily treat that biological dysfunction with a biological solution, with a drug or something like that. And I'm not saying, I'm not arguing against psychotherapy, against pharmacotherapy. I'm just saying that to keep the person in mind while you're doing that, and their psychology, is also important.
Brilliant. Very last question, an interesting one here from Wrangler. Nice name. Does the two-stage model leave room for agency in plants?
I would think so. I would be a proponent of arguing that there's agency of some sort even in microorganisms. So even in single-celled organisms are doing things for reasons where it's a holistic, integrative enterprise that's happening, where it's right to say that a bacterium is doing something, right? And I think it's right to say that plants are doing things as well. Of course, they do things in different ways. Like a lot of their solutions to problems are achieved through growth as opposed to movement. But they do a kind of a cognition, in a sense. They take in information. They use that information to solve some problems and then to mount an adaptive response to them. It's just that they do it really slowly. But yeah, so I'm perfectly happy with the idea of some level of agency, some level of basal kind of cognition even. I'm not going to necessarily go to sentience or plant consciousness, which some people go to. But they're definitely, I think all living things are agential to some degree and in their own ways.
Just reminded me of Dan Dennett's lovely little fancy that when he's discussing what people might do if they became convinced that they didn't have free will and they couldn't really make a difference. And he said, well, maybe they just sort of stop acting, and they just maybe trees used to be skipping around and running around, and then they got convinced that determinism was true and just took root and stopped doing anything.
Yeah, maybe. It is an interesting question to ask. What people would do if they really didn't believe in free will.
It is indeed.
Yeah, and do they just wait? Do they just wait to see what? Do they just wait to see what this physical stuff does in any circumstance? Go to the restaurant and wait.
Choice, though, wouldn't it?
Well, Dennett's point is that we'd just carry on, and that it wouldn't make any difference. That determinism makes no difference to us. We just carry on doing what we're doing. I think we could all agree on that, actually.
Yeah.
Well, thank you very much, Kevin. It's been a wonderful, stimulating discussion. Lots to think about.
Yeah, thanks, guys. It's been
everybody.
Really nice.
Everybody should go out buy the book.
Absolutely.
Free Agents: How Evolution Gave Us Free Will. Princeton University Press.
You'll learn a huge amount from it, and you'll be much better placed to engage with philosophical issues if you read Kevin's book. And whether you agree with his philosophical take or not, you will be informed and stimulated, and you'll learn a lot about free will.
Thanks so much.
We didn't get a chance to argue about panpsychism, but never mind. The more interesting
I was looking forward to that bit, Philip.
Another time.
Another time. All right. Yes. Well, thank you very much, Kevin. So we'll I'll put you backstage now. Say goodbye to Keith and hang around if you want to say briefly goodbye after we come off air. But thank you very much, Kevin. Keep Kevin. Up doing the good work.
Okay.
Yes. Look forward to the next book.
That was fun, wasn't it?
Yeah, he really agreed with me.
No, I don't think it worked this time. You always do this. Everyone agrees with me, really. But I think we had someone more on my side this time. But audience can decide.
Genuinely, I think he genuinely disagreed with both of us.
It's interesting. You are right to raise. I think Laplace's demon would really, get the answer. But then, like Lee Cronin, Kevin's, I think, if I'm understanding him rightly, so he's still listening to this, suggests maybe that's not a helpful or a coherent way to think. And that's interesting, because then we start to lose a way of like trying to make the distinction we're trying to make, which is an interesting thought that,
Yeah, no, I think it is. There's certainly a version of Kevin that maybe if sort of some quantum fluctuations had turned out differently a little bit earlier, he would now be very Donetian. You see, so there's certainly that was one possible.
Oh, so this is a new strategy. If the guests don't agree with you, you could say, well, someone kind of like the guest would agree with you. No, well, anyway, Keith, it's been a stimulating, and at the end of the day, we do have our disagreements, but I think we could, even Kevin as well, I think could agree that consciousness is wherever it is,
and where else.
I always forget to find the place where the button is.
Use your free will. Agency, man.